lesson, as I always say, and we are going to be starting on section 3.4, and we are going to start evaluating radicals, so putting numbers in there and seeing what they're worth, and looking at some of the more basic operations of radicals, so adding, subtracting, multiplying, even possibly dividing. And I am on page 46 in your pink note packet, and that's where we're going to get started. So the first thing we're going to talk about is when we try to take the square root of a number, the number inside that square root always has to be positive, because if it's negative, you get some error message on your calculator. So for instance, right now I've got some examples here, and if I did try to take the square root of a negative number, like -4, I would get an error message, non-real answers, because taking the square root of a negative number is not a real answer. It's what we call an imaginary number, okay? So what they decided, somebody, I guess, was that it's not good enough just to not take the square root of a negative number. There has to be an answer to it. So they came up with what they call imaginary units, imaginary numbers. And so they use I for imaginary, and they decided, let's just make the square root of -1 worth I. Now, I'm just totally making this up, that there is more math to it, but I'm not going to get into all of that stuff here. So we're just going to assume, since they couldn't take the square root of a negative number, they made up their number. It's called an imaginary number. And so what's going to happen is whenever you try to take the square root of -1, you're going to come out with the result of I standing for an imaginary number. And then you could also take this I and square it, because if I square this side, and then I square this side, if I square this side, I get I squared. And if I square this side, that square that I would write there and that square root cancel each other out, and you get -1. So the two big things to remember here is that if you take the square root of -1, you're going to get an I, and that if ever you're doing some math and you end up with I squared, it's actually worth -1. So this is more important for this section, and this is important for our next section that we're going to be in. So anyway, we've got real numbers and we've got imaginary numbers, okay? All right, so an imaginary number is in the form of bi. So b is actually a real number. That's what this is saying. B is the subset of all real numbers, and I is going to come from the square root of -1. So what we're going to do is we're going to rewrite these square roots that would normally be an error message on our calculator in its most simplified form. So one of our rules of radicals is they want as small of a number in there as possible. And we did this. We practiced simplifying radicals when we were working with the quadratic formula. So what we're going to do is we're going to take the square root of -4, sorry, and we're going to break it into the square root of 4, and we're going to break it into the square root of -1. So we're coming up with factors. And the square root of 4 is going to become 2, and then when I take the square root of -1, I'm going to put an I with it. So let's just try the next one, taking the square root of -25. Normally we couldn't do that, but if we break it into factors, then I can take the square root of that, I'll get 5, and when I take the square root of -1, I'll get I. Now in something like this, I'll still break it up into its factors, but 7 isn't perfect, and there are no parts of 7 that are perfect. So it'll actually just stay inside the radical, and I will just take an I for this. And usually when we write our answer, the I does go in front of the check mark, not behind it, okay? All right, square root of -200. So let's start out with just the square root of 200 and the square root of I. And then 200 is not perfect, but I can break it into factors that are 100 and 2, and then I'll still just bring this down. And then the square root of 100 is 10, the square root of 2 is still the square root of 2, and then I'll get an I from this. So 10, the square root of 2, and, sorry, I wrote that, and I had to put the -1 there. My fault. Let me back up, square root of -1. And then this becomes the I, so let me back up. I wrote I because I was really jumping ahead of myself. So this breaks into these two, this becomes 10, this stays the same, and the square root of -1 becomes I. And then when I write my final answer, we'll put the 10 first, then the I, and the square root of 2 last. The square root is always usually written last. So that's our big thing for this section, is what happens when you take the square root of a negative number. We're not going to say no solution, no, it doesn't work. It does work now. We can get I out of it. So let's practice evaluating. So let's start with this one. So I'm going to take the square root of x minus 4, and my function is f of x, and it's the square root of x minus 4, and this just says put 9 in where the x is, 20, where 3, where 1 is, and then we're going to classify them as rational, irrational, or imaginary. Now that's some vocab that you learned in Algebra 1, and I'll get to that once we get through this part here. So first I'm just going to take, this says put 9 in for there, and then I'll just subtract. And when I take the square root of 5, you know, I can get some decimal value. It's like 2 point something, but we're just going to leave it like this. So we're going to say our function, when x is worth 9, we get the square root of 5. And again, it's about 2 point something, but we won't worry about it. All right, let's put 20 in there. So I'm going to put 20 in for x. When I subtract those, I get the square root of 16, which, as it turns out, is perfect. It's 4, and so I'm going to write my function, when x is worth 20, I get 4 out of it. So let's try the next one. Let's put 3 in. So I'm going to put 3 in for x. When I subtract them, I get the square root of negative 1, and then this is where I need to remember that if I take the square root of negative 1, I get I. So what if I take the f and make my x 3, I'm going to get an I out of it. And then one more. Let's just put a 1 in there. All right, so putting 1 in there. So 1 minus 3, or sorry, 1 minus 4, I get the square root of negative 3. And then the square root of negative 3, we're going to factor that down. So I'll first break it up into the square root of 3 and the square root of negative 1. And then the square root of 3, well, there's nothing perfect about 3. There's no factors, just we're going to leave it as it is, and the square root of negative 1 is going to become the I. And then when I write my answer, my function, when I make x become 1, is I timesing the square root of 3. Okay? So big thing here, again, is we thought we couldn't take the square root of a negative number. We can, and it's called an imaginary number. And the square root that we'll be taking is always of negative 1. So we have to break it down into factors so that we can do that. So let's try this. So the big difference between this example and this example is this is a square root and this is a cube root. So square roots are where I run into issues. I can't take the square root of a negative number, but cube roots I can. So no matter what's going to happen, I'm not going to end up with an I in any of these because I'm putting this cube root of the number. So again, it's just practicing these values. So let's put 13 in. So 2 times 13 plus 1. So here we go. You multiply first, you get 26 plus 1. That becomes, the cubed root of 27. And the cubed root of 27 is 3. So my function h, when x is worth 13, gives me 3. And that's my final answer for this one. So let's put negative 1 in. So if I put negative 1 in, I'll do 2 times negative 1. I'll add 1. Again, I'll multiply first. When I add those up, I get negative 1, and I can take the cube root of negative 1. It is just negative 1. So my function h, when x is negative 1, gives me an answer of negative 1. Let's go for 4. So putting 4 in, so 2 times 4 is 8. 8 plus 1 is 9. And we are stuck. We cannot take the cube root of 9 and get a nice number. We can take the square root of 9, but not the cube root of 9. So for this one, I'll just leave it as my function h, when x is worth 4, gives me the cubed root of 9. And the last one, let's put negative 4.5 in. So the cubed root, 2 times negative 4.5, and then I'll add the 1. So this is going to give me 2 times negative 4.5 is negative 9. If you add 1, then that gives you the cubed root of negative 8. And again, I can take the odd root of a negative number. It's negative 2. So my function h, when x is worth negative 4.5, gives me negative 2. All right. All right, so on this page, we're going to talk about the function operations. And there are two types. There's adding, subtracting, and there's multiplying, dividing. So multiplying and dividing is always going to be the easier than the adding and subtracting, because adding and subtracting is very, very picky when it comes to adding and subtracting. You must have like terms. So before we start on that, let's just remind ourselves back from freshman year, Algebra 1, that if you have exponents, like a to the third, the a to the third just means that you're going to take a and multiply it 3 times. And so this 3 is called an integer. It's a whole number. But sometimes our fractions, our exponents can be fractions. And when they're fractions, then they're called rational exponents. So I guess at this point, this is a good time to go back and, which I just realized once I saw that word, that we didn't talk about classifying these numbers. So I just want to touch base on this. So rational numbers, irrational, or imaginary. So imaginary numbers are numbers that we're going to have an I in. So when I need to start classifying my answers, that's what I would do here. I would say that this is imaginary because I ended up with I. I'm going to abbreviate. This is imaginary because I ended up with an I. This one I got 4, and 4 is considered, you have to decide now, is it rational or irrational? So rational numbers are nice numbers. They're numbers that end. They're numbers that you have a short decimal or a decimal that repeats. They're fractions. But irrational numbers are very, very messy numbers, like pi. It's easier to write it in a different format than say its decimal format, because the decimal has no pattern to it and it's never going to end. So think of it as, if you have rational people and irrational people. Rational people are people you can reason with. They're easy to work with. And so are rational numbers, whereas irrational numbers are very messy. All right? So when I take this 4, that's a nice number. I can remember that, no problem. So I'm going to call this rational. It's easy to work with. But the square root of 5, that is not a nice number. If I actually tried to look at it in its decimal form, then the square root of 5, see that really long decimal? There's no pattern to it. And even though my calculator says it's ending, it's actually not ending. So that's what I would call irrational. And again, I'm just going to abbreviate these. So just going down to our answers down here, this is a really nice answer, something I can work with. So that's called rational. -1, nice easy number. So I'm just going to put an R for rational. The cubed root of 9, I don't know. It is a really messy decimal. Again, I could press the math button, access that cube root, put 9 in there, and again, there's that really long decimal. So this is what we would call irrational. And I'm just going to put an I, and then -2, nice number, so I'll call that rational. Okay, so quick little review there. Sorry about that, I totally forgot. Okay, so going back to this section, we are talking about rational exponents. So they are just exponents that are fractions, because fractions are something that we can turn into a decimal, and hopefully there's some type of pattern to it, it ends, etc. So the main 2 things to understand here is that you have a rational exponent, you can rewrite it as a radical. So if you just kind of take a look at the 2 different formats, notice that this little number here, the number like that might be the square root or the cube root, that's called the index number. That's the denominator of the fraction of your exponent. So notice here, the index number is n. Well, that's the denominator. And if you do happen to have an exponent, then that's the numerator. Okay? So for instance, if I had like 8 to the 2/3 power, I don't know what 8 to the 2/3 power is. I could put it in my calculator, but there's a chance if I rewrite it like this. So again, the denominator becomes the root number, called the index, and the numerator becomes the exponent. That I could figure this out, and I do. I could take, for instance, the cubed root of 8, which is 2, and then I could take that 2 and square it and get 4. But as an exponent, a rational exponent, I don't know what 8 to the 2/3 is. So sometimes we write things to figure out what they're worth. So anyway, let's go through these. So we're going to start with our multiplying and dividing. So we're going to have 3 times the square root of x and 5 times the cubed root of x. So we're going to set up what they want us to do, and then we're going to go back to here. So to find h of x, we just have to multiply these 2 functions. So 3 times the square root of x, and then we're going to take that times 5 and the cubed root of x. So first we're going to find h of x, and then we're going to use it to evaluate h of 1. All right? So what we're going to do is look at what they say for multiplying. So for a radical, in order to multiply, and again, this is a page you would want to have up in your notes when you take your test, they have to have the same index. So when I look at this, this has an index of 3, and this has an index, there's a little 2 there. So right now I can't multiply them. So what I'm going to do is rewrite them as exponents. So I'm going to rewrite it as 3, and the square root, just going back up to this, if it's just a square root or a cube root, that can become like a 1/2 or a 1/3 power. And this is all stuff you did freshman year, but it just seems like forever ago. So I'm just going to rewrite these as exponents. All right, and now I'm going to organize this differently because it's all multiplication. I'm going to multiply 3 and 5 together, and I'm going to multiply these x to the 1/2 and x to the 1/3 together. So 3 times 5, no problem, we got that, that's 15. So let's take a look at this. This is where it starts to get a little tough. So let's switch it out and put it into something that we do know. So let's just say, what if, totally different problem, this was x squared times x to the 3rd. Well, this would mean that there's 2 x's, and this would mean that there's 3 x's, and then I could add them up and realize, oh, there's 5 x's. So when you have the same base, hopefully you remember that you can just add those exponents up, and that's stuff that we've already worked with so far. And that's what we're going to do here. Even though these are fractions, we can still add them. So I'm just going to come over here, I'm just going to take 1/2, and I'm going to add 1/3 to it. And remember, when I add fractions, I need a common denominator. That's going to be 6 between these two. So these are both about to become a 6. I'm going to have to multiply the top and the bottom here by 3, and I'm going to have to multiply the top and the bottom, the numerator and the denominator, by 2. And when I do that, I get 3/6, I get 2/6, and then when I add them up, I get the 5/6.